Welcome to Chapter 3, Section 3, Focus of a Parabola. So, in the last section, we talked about attributes of a quadratic function based on vertex form and, certain attributes that happen, right, where it's increasing, decreasing, where it's opening up or down, stuff like that, and the axis of symmetry. But there's another way that a parabola is actually defined. A parabola can be defined as the set of all points x, y in a plane that are equidistant from a fixed point called the focus and a fixed line called the directrix. So no matter where you are on your parabola, if you know where your focus and directrix are, it has to be right in between those two. Now we're going to use that idea to draw a parabola, and we have to figure out, okay, well, what is happening here? Now P, there's this variable P in the equation, and it is the distance between the vertex and the focus. This is super, super important. Make sure you have it written down. Now the focus, if you look at this graph, if you look at the picture, the focus is right here, right? It's inside the parabola. The directrix is on the outside, right? That's that line. And then the vertex is right between the two, okay? The parabola opens toward the focus and away from the directrix. So it's not going to run into that directrix. The directrix is a line, and the focus is a point. So we're going to use these known things to figure out what the equations and the graphs of these functions look like. Now, they can now open up and down, or left or right, okay, depending on what the equation is. Now we're used to y equals, right? We're used to it being y equals something, so it's opening up or down, right? That's what we normally see. Now we're going to change it to where it can be x equals. And if it's x equals, it's the same equation, but instead of being h on the inside and k on the outside, it's going to be k on the inside and h on the outside. So those two just swap. That's all. So when we do this, the first thing we're going to do is graph it. We always want to graph them first. And it's just going to be a sketch. It's not going to be perfect. Now, if we look at our equation, what we really need to find first is the vertex, if we're given an equation. Now, the vertex should be hk, which we've seen before. So when it's hk, it's inside then outside, right? Well, there's nothing inside with that x squared. So the vertex is going to be 0 on the inside, and there's nothing on the outside and the back, so that's also 0. So if the vertex is 0, 0, we know that it's going to start at the origin. Now we have to ask ourselves, was this opening up, down, left, or right? It's y equals, which is what we're used to seeing, so it's either up or down. But it's up because it's positive. So if it's positive, it's opening up. Then we need to find where the focus is. Now it said at the beginning, the focus is what the parabola opens toward, right? So the focus is going to be here somewhere. And the directrix is going to be here somewhere, right? Some line that we can see. Okay, the question is, how far away is it? Because that's the thing. That's the important part. That's what's going to give us the equations of these things. So we know that P is the distance between the vertex and the focus. Well, in the formula, it's 1 over 4P. So here we have 1 over 20. So if 1 over 20 equals 1 over 4P, we really just have to ask ourselves, well, what times 4 would give us 20? Well, 5 times 4 would give us 20. So P has to equal 5. And that's this distance here. That's 5. So if that vertical distance is 5, and this is the point 0, 5. And if it's 5 up to get to the vertex, it has to be the same distance to get to the directrix. So this is also 5, but it's going to be negative 5 because it's below the x-axis. And it's y equals negative 5 because it's a line. So to answer these questions, the focus is 0, 5. The directrix is y equals negative 5. And then the axis of symmetry is the line that cuts it in half, which we've been doing, right? It's this line right here. Cuts the parabola in half. So that's x equals 0. Okay, let's do another one. Right, we are not done. I just want to keep giving you examples. By the way, this is example 2. So now we have this equation. Well, we have to solve it for a variable first, right? There's no variable by itself, and it's not going to be the quadratic one. So we need to divide by negative 16. So that becomes x equal to 1 over negative 16 y squared. So this is going to be a little bit different from what you just saw. Right, so we have our axes. Now if you look, the same thing happens here. There's nothing on the inside, so it's 0. And there's nothing on the outside, so the vertex is 0, 0. Right, because it's y squared, which means there's nothing here and there's nothing here. Okay? So we're going to start at the point 0, 0. That's nice. This time it's x equals. Well, x is horizontal, right? So it's either going to open left or right. Now it's negative, so the negative direction on the x-axis is to the left. So this is actually going to open to the left. And then, because the focus is inside, it's going to be somewhere in here, and the directrix is outside, so it's going to look like that. Okay? And they're equidistant from the vertex. Now to figure out what that distance is, we need to take 1 over 16 and set it equal to 1 over 4p. So what times 4 gives us negative 16? Well, 4. Specifically negative 4. Which means that this point is negative 4 spaces away. So 4 here and 4 here. Well, that's the point, negative 4, 0. And this is the line, x equals 4. So that's the answer. Negative 4, 0. That's a point, and the directrix is a line, x equals 4. The axis of symmetry is the thing that cuts it in half. So we've got this cutting it in half, which means that that is y equals 0. Now sometimes they give us information, you have to come up with the equation, but that's not hard either. So let's go ahead and do this. So the best thing we're going to do is graph it. So let's graph it. The point 0, negative 2 is down. So we'll call that 0, negative 2. And the line y equals 2, that's up here. All right. And this distance is 2. So because the directrix is 2 up and this is 2 down, p is 2. So now we can come up with the vertex. So the vertex is always going to be right between the directrix and the focus. So because the directrix is up 2 and the focus is down 2, then the vertex is going to be right in the middle, which is just going to be right here. Right? That's right in the middle. Then it opens around the focus and away from the directrix. So I'm not going to make this open up or left or right, because if I do any of those, it's going to run into the directrix. I actually have to open it down around my focus. So when I write the equation, first I know that my vertex is 0, 0. So that's helpful. Okay, because that's that point. I also know that it's opening down, which means it has to be y equals. It's opening down, so it has to be negative y equals. Okay, it has to be a negative number. So then we have 1 over 4p x minus h squared plus k. That's the formula I'm using. That was on that first page. Hk is the vertex, so it's 0, 0. P, well, we said p was 2. So y is going to be negative 1 over 4 times 2. And then h and k are 0, so we just put x squared. Well, 4 times 2 is 8. So that's the answer. Last one. We have a vertex of 0, 0 and a directrix of x equals negative 3. So again, like last time, like all of them, we're going to draw it. It gives us the vertex. It's 0, 0. That's nice. X equals negative 3 over here. So I'm going to have that vertical line. X equals negative 3. Now that means that this distance is 3. Well, if that distance is 3 and the vertex is right in between the directrix and the focus, then this distance also has to be 3, which means that there's my focus. Now, I don't have to know what the focus is. I need to know that P is 3, because that's the distance between the vertex and the focus. I also have to know and realize, well, hey, my parabola is going to open around the focus, so it's going to look like this, away from the directrix. Again, I don't want my parabola to run into the directrix. That would be very bad. So, because we have our vertex and our equation, the equation, because it's opening to the right, is x equals. Okay, it is opening to the right, so it's positive, 1 over 4p. Then y minus k squared plus h. And again, that formula is on that page before. Now, hk, again, because it's 0, 0, those just go away. We don't even have to worry about those. We just have to worry about this p value. So x is going to equal 1 over 4 times our p value, which was 3 y squared. Well, that's easy to simplify. That's just 1/12 y squared. And that's how you find the equation. Have a great day.